2 items to juggle. Right. Okay. Without anything better to do, let's begin. So, talk today is Essential GPT for development. Right. The only constant in life is change. The digital revolution. So what is the digital revolution? It was also known as the third industrial revolution. It was a shift from the mechanical to the digital and heralded the beginning of the information age. So, and what identifies this is essentially the adoption and proliferation of computers and digital record keeping, a big part of what we do. And here's a rough timeline of the digital revolution as well. So sometime in the 1970s, we had the rise of the PC. 1980s, we had the advent of the rise of the internet. Sometime in the 2000s, so there's a little bit of a gap here, but we had, came to the fore was Web 2.0, social media, and smartphones. And this is an interesting combination here. You couldn't really have one without the other. And basically, yeah, it was around this time that people started to share that information. It was readily, they also had access to these tools to allow them to do so. So specifically, with the advent of smartphones, it really enabled social media and allowed people to do things to share their information, such as recording themselves and yeah, put them up there on the Web 2.0. What happened is sometime in the 2010s, we had the rise of the cloud. And what cloud enabled us to do was actually end up with cheap storage and, of course, cheap compute as well, and be able to do this at scale. So not just locally, but yeah, across multiple regions. Okay, so there we are, sometime in the 2010s with the cloud. So what happened with the advent of the cloud was with cheaper compute, scalable compute, cheaper storage, is we had ready access to data. And as part of that as well, I guess historically, due to the limitations of having compute on premise, you could essentially just scale this out to whatever level that your provider allowed you to do. And so this allowed us to do a number of things, to train more and more complicated models and bigger models. So it was just really a case of time at this stage. And so what happened in 2017, we had this paper, Attention is All You Need, came out. And this is basically the rise of transformers, as it were. 2019, we had the GPT-2 was created. 2021, GPT-3. So if you recall when I'm looking at something, I've put a particular kind of context to this. So we've kind of got this kind of time frame where we're starting off with PCs, moving on to the internet, moving on to social media, etc., then moving on to the cloud. And we've kind of got larger time frames around this. But the particularly interesting thing is when we go to GPT-3, and then particularly ChatGPT at the end of last year, in terms of when it became readily publicly available, is you can see this time frame seems to be rapidly condensing. And one of the things to point out is, for example, with whether it's Twitter or with Facebook or whatever other kind of social network you might be a member of or have used in the past, these things, their growth exploded. So you know, these things are kind of counted in the millions of users. And the thing is for Facebook to go ahead to kind of first 100 million users, we're talking about a period of months or years to actually go ahead and reach that. ChatGPT managed to reach that in just 1 week. And here we are in 2023. We've got the talk about GPT-4, and GPT-4 has just been released, relatively recently. We've got Google's efforts with Bard. We've got Bing AI, of course, which is powered on GPT-4. Facebook playing around with BlenderBot 3, and there's a number of others. And yes, this is what I was talking about before. So yeah, sorry, it took less than a week for OpenAI's ChatGPT to reach 1 million users, and across the 100 millionth user mark in under 2 months. So there we go. So there's some specifics. Right, I do have references for a number of these slides if anyone wants to look up some of the information which I'm sharing here. Right, transformers. So what is a transformer? Transformer is a deep learning model and employs self-attention to identify patterns and relations within sequential data. So this last point here where I mentioned sequential data as opposed to words or text is quite important, because words or text are clearly sequential, but the concept of this deep learning and self-attention is applied to sequences of data. So it does not necessarily just have to be text. And you'll probably be aware of that if you've had a look a bit about GPT-4 or seen the release for that. They're actually starting to, it's a multimodal model, which I'll go into shortly. But the point is this capability to identify sequences, and this is probably one of the big takeaways you need to keep in mind when you're looking at GPT, as opposed to just collections of text. Deep learning, as opposed to just learning, indicates there's a large number of layers in the model. And self-attention is the mechanism which allows the network to identify the relevance of nearby tokens, or how it actually identifies the relationship between So I'm mentioning the word tokens here as opposed to words, but you can imagine that could be an arbitrary piece of data, or it could be, for example, something monitoring a machine, or whatever it is, in a given sequence and how it relates to other ones. And a GPT is a generative pre-trained transformer, and it's a language network architecture suited for identifying relationships, once again, within sequential data. So this is kind of a very important point here. Okay, so how do they work? We've got a diagram here from one of the papers, and you'll probably see this discussed in a number of places. So in the context of predominantly, when we're talking about large language models, so language models speaking about words and text specifically, the words are encoded in something called byte pair encoding tokens. So they roughly equate to 3/4 of a word. I could go ahead and open up a screen and show a demo of that, but specifically keep in mind that these language models aren't necessarily just optimized for English, and of course, as far as the English language goes and other languages, you've got a concept of stems, etc. So in many cases, the relationship between a word and a token is not necessarily obvious. So specifically, in some cases, it will often just be the word plus a space or something like that, because in terms of how they're represented within a sentence. But other cases, it could just be parts of the word. So like, for example, the word hamburger, it does not represent a token itself. It's made up of 2 tokens, for example, ham and burger. But you can also probably appreciate where this can be used for different languages. So one of the things which kind of indicates what this kind of token transformation relates to is basically how often these words have appeared in the sequence initially. So I guess probably the important takeaway here is when I'm discussing this model and moving forward, you're going to see this term token pop up multiple times, and that's essentially what is limiting the information that you can put into the model and what the models are essentially working with. Right. Yeah, so these byte pair encoding tokens are fed into the model in a buffer called the context. So once again, this is another particularly important term. So context and tokens are 2 big takeaways when you talk about these models here, of a fixed length. So the thing is that it's not an endless stream of data which is going into these. These models have got a fixed, essentially, width of each one of these kind of attention heads within or within the network, and they're constantly being improved. So if we're talking about, for example, ChatGPT, it's got a certain length, and it's got a context length of about 8,000 tokens. But we're talking about, for example, GPT-4, which is, I guess maybe ChatGPT is going to become GPT-4 in terms of the naming. I'm not too sure. It's got a context length between 8,000 and 32,000 tokens, depending on which variant you're using. Okay. The tokens are embedded into vectors with position. So the vectors concept of vectors is fairly important as far as machine learning goes, and when we're actually working with these particular models. But it's just essentially a way to kind of represent them in a given space in terms of how they actually relate to each other. So how the word hamburger relates to fries is going to be different to the way hamburger relates to, for example, politics. And so this is, as you can imagine, these tokens have got multiple representations, and so you can imagine, in terms of this concept of, I'm just going to refer to it as a semantic space, or in terms of how different words relate to each other, you end up with multi-dimensional vectors. So hamburger might be closely related to fries, so this particular part of the vector will be similar to the fries vector, but it'll be quite different to the politics vector. Now, once again, politics isn't necessarily a verb, so there's going to have some commonality there between, you've kind of got a noun comparison there. So you can imagine there's a lot of different aspects to these vectors in terms of how they're represented in the machine, or sorry, inside the model. Okay, so this sequence of vectors goes through attention heads for contextual encoding. We did have some extra things here, but I won't go into the technical detail of that, how that works in terms of keys and values and kind of mapping through that particular process. But the point is once they've gone through the attention head, sorry, I've got a reference here. We've got the kind of next step. It creates a new sequence after it's gone through one of these attention heads. So you're looking at the model here, and we've got this concept of attention heads. We've got the NX is indicating that they've got multiple layers of that. And basically, once it's gone through attention head, it's got a new sequence, and it's fed forward through memory. So this kind of additive normative layer that we've got there is the kind of concept of memory. So the thing is, as a result of this kind of calculation, or the way it's kind of represented, these is actually stored within that level there. And so what you can probably appreciate as we go on, we've got a number of things with, sorry, I've got some specifics there for the old one, and that's pretty much just propagated through the model going ahead. So specifically what we're talking about there, as you can imagine, is presented with a particular sequence of tokens, and then that token finds some sort of relationships between them, and then goes ahead and abstracts that away in this kind of concept of memory. And then that's repeated, so you get further and further levels of abstraction within the model. So it gives it the ability to...
Sorry, you're breaking up. Can I get you to speak into that a little
Sure,
bit?
okay.
Just to see.
Is this a little bit better? It appears to be, judging by the...
Sorry.
Yeah, no, that's no problem. Thanks for pointing it out. Right. So this process repeats, and the model develops further and further abstractions of the initial words which are presented to it, and that way it forms a number of relationships. Okay, this is propagated number through, then we've got finally a process where we've got a weighted outputs are produced, and then essentially makes a decision based on the probabilities there. So the thing is, to be clear with these models, is there isn't a fixed answer for any kind of given question. There is a number of points where you've got a number of kind of candidate responses that it could give to a given question, or I should specifically say a sequence of text. In the context of ChatGPT, we're talking about questions typically, but it is just a sequence of text that we're looking at. And basically, depending on the probability, well, depending on how likely a particular choice is, it will impact the decision there. And you can kind of tweak those probabilities. So for example, there might be 10 different options to complete a given sentence, or 100, or you can imagine it just scales out depending on, or to end a particular series of sequence of words is probably a better way to explain that. And then you can play with the probabilities or the weightings there in terms of producing the result that you want. So when you're looking at things, for example, working with Bing AI or the GPT playground, you've got the ability to change these to either make the response a little bit more creative or a little bit more precise, a bit more succinct. But keep in mind, there's still, regardless, a randomness factor in there. And essentially, what happens is once it's produced the result, it's added to the context. And so you would see this kind of concept of context. The context I'm referring to here is the same context that we're talking about in the first place, and this is bounded by the limit. So when we're talking about ChatGPT, we've got an 8,000 token limit within the context. And specifically, what that means is depending on which model you're using, they've got a certain length that is available in terms of when you're actually asking a particular question or providing a text prompt to it, in terms of how it's only going to complete that. So you can imagine if you had a 4,000 token prompt, you've only got 4,000 tokens available for your response, as an example. It depends on how the model's configured in terms of when you're actually using this, but you're simply limited to the 8,000 limit. So the shorter the question, in theory, the longer the answer can be. But once again, it depends on how that particular model has been tweaked. But you're still limited to this 8,000 response. So you can imagine if feeding 4,000 tokens, as mentioned before, you're going to be limited in your response. You're not going to get it to write an entire novel for you, for example. But as I mentioned before, with GPT-4, it's a similar kind of concept governing that. You've got up to 32,000. That gives you a lot more tokens to work with, but that's still going to be approximately, perhaps 24,000 words or something like that, typically. And so, this context is processed until it fills the buffer, so it fills the 8,000 token context, or it reaches something called a stop sequence in terms of indicating to the model that it should stop producing its response. So that's just a high-level overview in terms of what's going on there. There are references to it. I've got a link on the previous slide in terms of if you want to dive into this in a little bit more detail. And here we go. All right, so one thing is how's ChatGPT different to GPT? And this is one thing which popped up in my mind when I first heard about ChatGPT, because I heard people mention ChatGPT and I was thinking, don't you mean GPT-3? And I was a bit confused from a terminology perspective, but there are actually different things. So GPT-3 is the base model that ChatGPT is built upon. ChatGPT is a GPT 3.5 series model. It's a fine-tuned, smaller version of GPT-3. GPT-4 is, once again, slightly different from this, and I'll explain some of the differences there. But specifically, the point to keep in mind is this base model that it's built from is further refined, and one of the things they're doing is reducing the parameters and applying this kind of concept of fine-tuning, which I'll describe later in terms of what actually differentiates ChatGPT from the base model. And similarly, what differentiates GPT-4 compared to ChatGPT as well. But a lot of that work is within this fine-tuning. So 3.5 series models of note are a GPT 3.5 Turbo, chat-tuned model. So the base model isn't tuned to chat, and this is what I was talking about before when I was trying to distinguish the difference between a sequence of text and questions. And there's another one which other people might be somewhat familiar with. So if anyone in this room or in this particular meeting has used Codex or the new GitHub Copilot, it's using the Code DaVinci 2 model. And this is once again a derivative of the ChatGPT model and within the 3.5 series. Keep in mind this is different for Copilot X, which is, I'm not too sure, I don't think it's out yet, but that's got a GPT-4 base and a couple of things which are different there. And I'll explain also why I don't have further information regarding that. Okay, but what happens is new versions of each model series are released on a regular basis. So when you're talking about ChatGPT in terms of what's typically publicly available and what most people are familiar with, the lifetime of these models is typically about 3 months before it's rotated again. So the thing is if you're working against one particular model, this is from a development perspective, you'll typically want to be using latest all the time, as it were, because they've essentially got a 3-month lifespan for this. So when you're working with ChatGPT, the model's been updated on a regular basis, and the old models will simply cycle out based on that sliding window. And these models I'm mentioning here, in terms of GPT and Code DaVinci 2, they're available in the OpenAI playground. Specifically, there are a couple of things around OpenAI. Might be some people in this room who've got access to GPT-4. GPT-4 access, at least historically, or at least last time that I looked at it, was partially governed based on what type of research you're doing, and also governed depending on if you work in the US or not, at least initially from my understanding. Right, got some references here. Okay, so GPT-4, I've already touched on this and probably covered most of these points already previously. So GPT-4, it's once again tying into this context or this statement that I made earlier in terms of this identifying patterns between sequences, in sequences. And specifically, we're dealing with a multimodal model here, which can accept text and images as input as opposed to just text, and produce text as output. It's differentiated by more fine-tuning by a network, and I guess to be a little bit more specific about this, there's been significant work has been done to reinforcement learning with human feedback. That's another topic I won't necessarily cover this evening, but specifically some of this can be automated, and a lot of these improvements have been made through the automation of some of those processes there. We've kind of got the capabilities now that newer models are actually capable of training early models, and early models with less parameters as well. So one of the things is, you'll find with some of the research which is going to GPT-5, there's a kind of a law of diminishing returns as far as this goes. There's not going to be any significant improvements, they believe, following this particular path. And so the thing is they're not too sure what that kind of magic number is, and obviously that may change over time. But we're finding that some of the models with less parameters, as opposed to the 150 billion for GPT, or GPT 3.5 at least anyway, or ChatGPT, are able to be trained by, so we've got 150 billion parameter models actually are able to train, for example, a 15 billion parameter model. So there's a kind of interesting trade-off there in terms of how complicated these models need to be, at least in that aspect anyway, from a parameter count. All right.
Can I ask the clarification of the gap? I know what a GAN is, but a gap.
I think they referred to the term as generative adversarial program, and I'm not too sure what it was. It was speculation there, hence the question mark on there. So that's the thing. That there's only so much information which is unfortunately available with this, as far as someone who's just part of the public. So I can't really give a definitive answer apart from what they've got in their papers. So the interesting thing is GPT-4 is developed on a supercomputer jointly designed by OpenAI and Azure. So you're going to see this Azure's thing coming up quite often. And once again, I don't necessarily have the information about that. And I mentioned the context token of up to 32,000 tokens, or approximately 24,000 words. And enables customization of behavior via system messages. I'll touch on this a little bit later on the talk. But specifically, they've got a dedicated section of the prompt, or from what I've seen, at least in the demo, to go ahead and contextualize the model in terms of the types of responses you want to give it back. And I've got a demo going on later tonight, not with GPT-4, but with an early model demonstrating such functionality. And it does still hallucinate and can be jailbroken. So when I refer to the term hallucinate, it's actually a particular machine learning term, which indicates that the model is essentially producing nonsense. It's just somewhat amusing. I guess it can be applied for people as well. And jailbroken, anyone somewhat familiar with this? I do mention a little bit later on, but if you've seen the whole thing about Dan towards the end of last year and earlier this year, where they're trying to get ChatGPT to kind of break out of its constraints and behave perhaps unethically, depending on how the reinforcement learning and human feedback's been applied to it. Even no matter how sophisticated the model is, at least at the moment, can still be jailbroken by this kind of concept, as you can no doubt imagine, sort of nesting or inception. You can go ahead and essentially virtualize a machine within the machine in terms of how you've done the prompt, and get it to behave essentially in an arbitrary fashion. You can probably appreciate it's essentially turtles all the way down, in which case it's almost very difficult to train the model around that, specifically because there's kind of randomness factors in the number of parameters. You can imagine the combinations you vastly exceed, for example, the number of atoms in the universe. There's a very common kind of analogy there, but it is just simply infeasible to go ahead and try and produce a prompt or the appropriate human feedback, or even machine-generated feedback, to cover that many permutations. And GPT-4 is available on ChatGPT Plus from OpenAI. It's also available on Azure as well, but there's 2 levels of application you need to go through to go ahead and access that. Right, and it's still trained up onto data up until the end of 2021, at least the last time that I looked. This is a couple of things, but there are also ways to work around this as well, which I'll explain later on in the talk. Right, reference here. One of the probably the most painful things about the GPT-4 information as opposed to GPT 3.5 or ChatGPT in general, OpenAI were kind of living up to their name and providing a lot of information in this. So there's a handful of papers which are available to go through here for the index for researchers, etc., to find out some of these details. Because of the competitive nature of this landscape, and clearly there's a number of major players in this space, all wanting to get an edge on each other, and of course makes a lot of sense because there's been heavy investment in the last how many years, specifically, once again, tying back into what I was talking about, the evolutionary timeline, and we're talking about the cloud and the compute being available. A lot of this information is not available anymore. So when we look at the papers produced by OpenAI regarding to GPT-4, most of them are regarding performance improvements and a couple of other things like that. They don't necessarily go into the size of the model and a number of other things, which I'm going to touch on later. Right, so talking about some technical details here, unfortunately these ones are mostly going to be around 3.5, but I'll kind of give you an idea of how it works. From a perspective, just like most machine learning models, it's written with Python. And the particular library they're using is PyTorch, which is produced by Facebook. There's a number of different libraries out there, whether it's TensorFlow for Google and a number of other offerings. It runs in Azure, of course. It's sort of mentioned of Azure before, and of course, once again, with the partnership with Microsoft, it's a bit of a no-brainer. And at least GPT 3.5 was trained on a 7,500 node Kubernetes cluster. So it's a decent sized cluster there. And I was just having a brief discussion with Todd earlier tonight, and he was talking about, some things have got thousands of AI specific I'm not too sure if they're called GPUs anymore in this particular context, but this was just GPT 3.5. So I've got no idea how big the supercomputer was for GPT-4, except it clearly was Titan 1. Once again, I'm sure it probably can be readily found out internally. But if GPT 3.5 was done on, GPT-3 was done on 7,500 nodes, you could probably appreciate it's probably bigger. And from what I understand, it's one of the largest supercomputers in the world now. I can't remember where it's ranked. Right, and trained on NVIDIA A100 GPUs, I think it was, as opposed to V100s. I might have to, not 100% sure about this one. And yeah, as I mentioned before, information on GPT-4 is not available due to competitive pressures. Right, so that's interesting. So how are GPTs taught? So there's a number of things. One of it is training, aka pre-training, that's a specific term that's used. And the other one is aligning, aka fine-tuning. So the thing is, once you've done the training, so we're talking about, for example, GPT-3, it's been trained, but then that model needs to be aligned to, one thing is to be able to, for example, answer questions properly. Because all it's essentially doing when they just perform the initial pre-training, a vast corpus of text is fed in, and all it provides the model the ability to do is predict what the next token is in the sequence, essentially. So this part here, aligning or fine-tuning, is where we get the ability of ChatGPT and what distinguishes ChatGPT from GPT-3, for example, and GPT-4 is clearly following a similar kind of path in that regard. The other way that can be trained is via the context, but they can't be updated. So specifically when you're asking GPT questions online, it depends on which model that you're communicating with. Depending on the details of the particular agreements, sometimes your data will be kept private, other times it won't be, so just be very mindful of that. There was particular things, so specifically when I was going through the model before in terms of how it works, when we're interacting with it as a public or most users with the trained model, and clearly a big part of it is not being able to train it yourself because it's somewhat expensive to spin up a 7,500 node Kubernetes cluster and run it for a bit. Exactly. The context or the questions that you're feeding it through aren't updating the weights within the network. However, it doesn't mean they're not being filtered beforehand and recorded. So it just depends on what phase the model is in, and of course, reading the fine print there. So just be very mindful of that. I cannot overstate this enough. Some of you in the room might, or in this particular meeting might be aware of, for example, the Samsung semiconductor leak, where Samsung employees were putting in details of some of the semiconductor research, whether it's just summarise or TLDR or published papers on it. Of course, that went into the training and it's now part of the model. And tying back into what I mentioned before about social media and a couple of other kind of impacts of that, any data which is fed into there, it's pretty much impossible to extract from something that complex now. And as you can imagine, these models have been built upon previous models as well. So any of your data which is in there at this stage, they're simply not going to be able to remove it. It's just not feasible. Right, so I mentioned pre-training before. So pre-training uses this concept of unsupervised learning, and this one's quite interesting as opposed to supervised learning or reinforcement learning. So what happens in unsupervised learning is essentially just injecting as much text as possible into it, meaningful text I guess it is, and it gets to form this kind of concept of a semantic map again. So you will recall earlier in this presentation, I mentioned this concept of vectors and vector space. It's building up a kind of mapping when it's doing this unsupervised learning, and it's not given any particular instruction how to do that. So it's just given a lot of text, and it starts forming its own semantic map. So there's no instruction saying, okay, hamburgers to fries as, you can imagine another appropriate analogy there. It is working all this out itself. So that's unsupervised learning. Typically, the more data, the better. However, there might be some limits. And this is how GPT-3 was trained. Once again, GPT-4 information, from what I understand, it's going to have a lot of overlap with this, but because the papers haven't been released giving the specifics about it, this will give you an idea of the type of data which goes into training these models. So specifically, there was 5 main sources here. The Common Core, this is available, so I've got the websites for these if anyone actually wants to see what the data is going into there. And there's approximate token counts there. So I did actually update this slide. This is copied from the research paper. For some reason, it said 3% here, which doesn't add up to 100%. So I've probably done something wrong when I've changed that 3% to 2%, but it did bother me the first time I presented this. But specifically, yeah, these are the sources, and keep in mind they don't just pump this data through. This is the raw data, and then it needs to be curated, filtered, etc. accordingly. But some of that is missed, and some of that's also missed in some of the advanced models, and you end up with some very strange vector embeddings within this space, which can actually make the model spout nonsense. So, for example, I'm just going to give an extreme example here. So we'll see, if we look at here, WebText2, where we're working from Reddit, there's a particular subreddit in Reddit. It's called the counting subreddit. And I assume it's probably mostly bots these days. And the idea is they just keep on counting. So each subsequent post is plus one of the previous post. And as you can imagine, there's a couple of users popped up fairly regularly. And these weren't filtered from the initial data set that went into there. So there's going to be some odd tokens, if you remember me mentioning about these byte pair encodings, which represent these particular users. And you can imagine the type of names which come up on Reddit and other kind of things there. So you're kind of ending up with these kind of nonsense vectors, and it's possible to go ahead and prompt it.
Just a question online, how's performance monitoring done? Yeah.
That's right.
Performance monitoring of the model itself, or the performance? I just need a little bit more clarity on that question.
Primarily, what I mean, when you have developed a model or something, in terms of the performance monitoring, how is your model is performing in the context of any database or any machine or any server, we do some kind of a performance monitoring, how things are running.
Okay, I can only lightly touch on this. So keep in mind, there are models available which you can download and install on your own hardware. GPT and the GPT models are running on somewhat privatized. So you cannot go ahead and access and download these models, and especially can't download the weights. So they're running on Azure hardware for the most part. There might be some elsewhere, but that's the best of my knowledge. So specifically, you're not going to get the insights in terms of how that goes directly apart from the services which are available in Azure, or the services which are available in OpenAI. So specifically from the OpenAI perspective, there's probably some things around from a developer perspective. So if you get the API access, it might give you some insights there, but specifically, I believe that's a managed service from the OpenAI perspective. From the Azure OpenAI perspective, they do have a couple of things around models. I'm not going to open up the portal now, which controls how scalability and a number of other things like that, but I haven't fiddled with all the knobs, etc. around that. One of the things is it's still a multi-step application process to get there. There's no doubt going to be some flux or change in terms of when it's actually finally released, or perhaps it will stay relatively the same. It's hard to say. I haven't delved too deeply into that, but there is the ability for them to scale, and I assume there's going to be auto-scaling there from what I've seen. But I cannot give you a more definitive answer than that at the moment without probably doing a quick search and coming back to you. So hopefully that covers your question at least as well as I can answer it.
It says thanks.
Okay, great. Thanks. Okay.
Is it only smash words that are picked for books one? There's not the smash words has an interesting collection of books.
Yes, so keep in mind, I did mention at the start of the slide there's a curation phase. So what gets curated in and out, that is not published in the paper, and that's part of the magic sauce in terms of how GPT behaves, but performs well, how it does compared to other models. So that will likely remain somewhat secret. I can't see a benefit for them to release all that information right now. So I can't tell you how these are being filtered, except some things have slipped through the gaps. And so as you can imagine, that's why there's this kind of significant phase of reinforcement learning with human feedback to try and reduce some of that, because to unravel that, to retrain the model is somewhat expensive. Books 2, there's speculation in terms of what that is. I don't know for sure what it is. You could probably have a quick look around. You'll see a lot of speculation and suggestions what most likely is, but there's no definitive source available. So whereas the rest of these are pretty much verified. for some facts here, the internet is approximately 5 billion gigabytes. This is from the Google CEO anyway, and the common crawl is a mere 570 gigabytes. So you can imagine the difference between 5 billion and 570 is significant. But do keep in mind, in terms of distribution of data on the internet, there's a lot of noise, I guess is probably the best way to put it. So in terms of what's in the common crawl as opposed to actually trying to download the internet, as it were, I'm not too sure if it is going to have significant gains in terms of some of the content that's out there, at least anyway. And yeah, the reference once again, for anyone who looks this up, I can share the slides later. Okay, so that was pre-training and training. The next part is fine-tuning. That's where things start to get more interesting. It makes the model seem more alive. So I'm going to use some analogies here. It's probably the easiest way to describe it. You can substitute your own words, but hopefully you get the general gist of where I'm going. So fine-tuning is what allowed OpenAI to incorporate their goals and preferences into the unconscious model. So the two terms I'm going to use here are conscious and unconscious. This is just an interpretation. This is a simple way to describe it. There's obviously a lot of discussion on this front on what's conscious and unconscious. But you can imagine there's something predicting the next word given a particular sequence is no real kind of conscious control over, or no control over it. Whereas this concept of reinforcement learning with human feedback, it's a focused effort by humans, and of course how the individual programs have been optimized to perform this. There's been a conscious effort into that. So as opposed to this kind of unsupervised learning which formed the internal representation in the first place, so you could argue that's unconscious, there's this kind of conscious effort to go ahead and shape the answers in a particular format, or make the model start understanding how to answer questions. And so yes, reinforcement learning with human feedback I've already touched on, and there's a bit of a concept on this. You can visit the site and find out more details about this. Essentially, the model is prompted, it gives a number of responses, and humans rate the appropriate responses, and the most favoured responses fed back into the model and suggested this is how you should shape future responses in this. Due to the complexity of the model, it's not going to give that fixed answer that the humans given back necessarily, but it will adapt that into its responses. And yes, just some more technical detail. Function determines the difference between the ideal text and the actual text produced. And the model is updated to minimize the difference. So this is the important thing here. It's not to replace it, it's to minimize it. More simple models will simply do a replacement, but in terms of what we're actually interested in talking about here, it is, it will minimize the difference. So that means you're not going to have constant results. And GPT, as mentioned before, can now train its less powerful siblings, which is interesting. So some documentation here. So how to use GPT. I'm just going to breeze over a lot of this, the fundamentals. A lot of people here should be somewhat familiar with where I'm coming from. So it predicts the next element of sequence based on the context and words most commonly seen together in that context. It will generate plausible sounding statements based on the above. So no, plausible sounding, and not in terms of factual. There's a whole thing in terms of what's truth and not truth in that regard, or subjective and objective truth, but I won't go into that here. But they may or may not actually be true. So this concept of hallucination as well. So how should we use it? Creative purposes, it is absolutely fantastic in this. In fact, the creative industry is under a lot of threat right now because a lot of content can be generated. And if you embrace it for what it is, at least in this aspect here, it can simply produce things in a vastly shorter time frame than humans will. It produces great results, and the industry must adapt. That's simply a fact. In any creative industry, you have to take that into account. I'm just going to do a little bit of an anecdote here. I did a variant of this talk earlier this month. The person who presented before me was a designer, and we tied our talks in together. We were talking about kind of GPT, it was somewhat earlier. And basically, it's a story of a copywriter who just started off a business, had some degree of success. She was writing documents essentially about data centers for the most part. The customers didn't see as much value in that anymore with the advent of GPT. Her business dried up. She ended up having to look around for another job. She ended up getting a job marketing at a particular company, from what I understand. And one of the interview questions was, are you familiar with GPT? And that was as recent as February. So to give you an idea, it is changing even the interview process in some fields. And the best way to look at it is as an army of interns, okay? So specifically what you need to do is, obviously when you're working with interns, you can have intelligent, quite competent ones. However, for the most part, you're going to want to verify the answer. And this is probably the biggest takeaway here. So always view it as this, regardless of what it's producing. So it might sound extremely competent and might produce extremely good results. However, it is always worth checking. Do not get it to do things that you do not know how to do, because you're not going to be able to validate the results. So yes, specifically here, you need to know what you're looking for in advance to be able to verify the result. And another killer use case is to perform tasks that take you longer to do. And there's a lot of tasks which take you longer than 2 seconds to do. It's fantastic at summarizing and extracting information. And so yeah, moving on to the type of prompts that we can actually go ahead and give it. So this, I'll cover this in a minute. So when I was talking about GPT-4, we've going to give this concept of impersonation. So I want you to become a prompt creator. This is an extreme prompt. There's many ways to do this. Guys, help me craft the best possible prompt for my needs. The prompt will be used by you, ChatGPT. You will follow the following process. You can look, there's plenty of these up. There's plenty of, on the internet, plenty of prompt experts. I can give some very basic information, but there's people certainly a lot more knowledgeable than me in this front. Transformation is the other thing. Translate this French into French, Spanish, and Japanese. And summarization. These are the three killer use cases. So if you put your prompts together like this, you are going to be, this is the most common route to success. So explain like Oven 5. Once again, this concept of jailbreaking that I mentioned before, you can just look up Dan if you want to actually see what the latest way to jailbreak based on impersonation is. So,
another question, is there any information created / generated by ChatGPT has copyright issues?
that is a very good question. I can't answer that. Keep in mind the information that went into the model. There was a curation phase. There's also from some of those data sources, Reddit, Smashwords, etc. Any post with 3 links. I cannot answer that question, and I'm afraid that a lot of people who have worked in putting the model together may not be able to answer it. And even then, just moving forward, even if there is some information in there, they're not going to be able to extract it. Right. I'm going to talk about Copilot briefly. This is just from GitHub Copilot, but I'll talk about Office Copilot as well. From a coding perspective, these are the some of the languages it knows best. Once again, we've got some references here. From prompt fundamentals, we want to specify the language and the version. We just want to specify libraries and provide a queue to continue from. This is from a coding perspective. Don't get it to write difficult logic or long functions. And we've got some best practices there. So specifically, it's not going to replace developer jobs right now, only the very simple cases. In sophisticated cases, you can pretty much forget about it. Because of this concept of hallucination, the context length limit, and a whole lot of other kind of factors playing into it. If you're putting together some complicated apps, you've got to do a lot of prompt engineering to get it to produce the right result, and it's simply faster and easier to do it yourself in many cases. This may no doubt improve, but I do not see it as an issue within at least the next couple of months, next couple of years. However, that does not mean it won't be a very different story in 5-10 years. Okay, so generate simple code. We've got an example here. A method that takes a generic list and package page as input. This is one that I did myself. It was just something to do for a test case to put it out, and you can see the kind of prompt here. We're saying, okay, public, so it's going, oh, okay, I'm going to write a method which starts with public. So we're giving it a fairly high chance of success. Just ignore the slashes here because there should be multiple lines, etc. But assume that's not wrapping. Okay, we've got another one. This is a killer use case. I've had some clients that I've done some work for, solving some issues with stored procs, especially ones which go 6 or 7 levels deep and fail because they didn't have transactions around them and a couple of other things like that. Bit of a nightmare. So I've just got a very simple case here, but you can imagine feeding in those particular code or statements in there and just say, provide a brief description of the bug query in simple English. I do have an example later on this, but you can imagine you can mass load these into the system. You can automate this part, and it can generate rudimentary documentation. Once again, because this kind of 2-second rule, it often takes me longer than 2 seconds to read through a 100-line stored proc. Call me slow, I'm not too sure what it is. And the thing is, it will often produce results of an equal level, and in some cases better than I will, also produce ones worse than I do. So first pass, certainly put it through, and then you can go ahead and look at the parts which interest you. And shell scripts is this thing which I don't really do very often. It's only every couple of months when I'm just doing a new deployment or something like that, I need to remember my PowerShell. And there's a very kind of simple common one here, but you can imagine you can go from there. So that's the other very common use case. And of course, unit tests. Okay, using the GPT API where things start to get a little bit more interesting. Okay, getting started. GPT models are available via RESTful API. Sign up for a developer account with OpenAI or apply for the Azure access. Get an API key and use a tool such as OpenAI.net. This is the basics. So this is what most people are at least looking at initially, but there are far more complicated advanced tools with this. So in fact, I probably should have updated this slide and just removed this. It's a valid way of doing it, but this is just kind of the first step. People go, oh, I'm going to talk to this programmatically, when they should be doing something else. Okay, so this is where things start getting interesting from a business perspective. How do I use your own data with GPT, assuming that you get around this kind of privacy constraints, get a model deployed just for you, going through the appropriate license agreement, etc., working out what applies. So from understand, I can't necessarily speak for the details for Azure, but from understand for one of the offerings that OpenAI are looking at as kind of this, I'm not too sure what the offering's called, a business offering in the next couple of months where they're trying to work out that they're not actually going to collect the data. At least I know for some of the Azure stuff it will, but I think that there's probably some caveats around that you can go ahead and say, no, do not collect my data, but I cannot speak for that for sure. Right, so using your own data with GPT, pre-training, no, unfortunately. This is that kind of 7,500 node cluster or even bigger. They're just not going to do it for you. However, yes, it's cost prohibitive and the work has already been done. However, we've got these two other kind of cases, fine-tuning and context injection. So in context, we're going to use something called prompt injection. And this concept, and what we can use with context is actually go ahead and put use some embeddings there in a semantic map, which I'll just discuss shortly. And then finally, we've got kind of fine-tuning. So pretty much the main tool is kind of context injection, and you can use embeddings to do some really amazing things with that, or fine-tuning. So in context prompt injection, it's impractical to inject information in the prompt due to context length. I've covered that before. So here's some kind of basic steps. So this is the kind of thing how kind of when you're looking at with Bing AI or a lot of these other things, this is how they're kind of working under the covers, and I've got a more comprehensive example shortly. So when the question has enough information to query the index, fetch the top X results in line with instructions in the question itself. When you've got an ambiguous question, when the context is important, use ChatGPT to summarize the question into a query. So someone spelling out half a life story and then the question is really kind of interspersed amongst. Because it does have this kind of language comprehension ability, you can go ahead and simplify that. So you can imagine putting this behind an API of some sort and perform these kind of operations. And when you've got a kind of nuanced question, use ChatGPT to decompose the response into small steps with links. So I assume a lot of you probably use Bing AI by now, but depending on whether it determines to do whether it's available in its internal model or it needs to do an internet search, it returns internet search with the references, and then depends on how specific that you want it to go. But there's the kind of general steps that it's following. So yes, and yeah, essentially this is how Bing AI works. Once again, yeah, from the Microsoft space, Revolution, yeah, a link there. Okay, so this is things where things get really interesting. So Microsoft Semantic Kernel, it's relatively new. It's still in alpha. This is my 4th talk this month on GPT and development with it. And to give you an idea, I've had to redo this talk maybe just in preparation for this talk. I've redone the demos for this. The previous one I did Microsoft Semantic Kernel as well. The one before that was just using some basics around the first API that I showed before, and then the one before that I was just talking about the theories. And the point is this space is moving so quickly now, whereas it might appear that I'm mostly ahead of at least a lot of people in this room, not necessarily all of them, I cannot keep up. So I might be ahead of just say 98% of the curve in terms of for someone who's not working in the space, but there's such a vast gap between where I am and the people on the cutting edge, just to be clear. And so when I was going through that time frame before, you kind of imagine, perhaps I should have had a slide, this kind of exponential curve here. So the thing is, the rate that releases are coming out, it's several times per day. And the fact that I'm prepared a talk last week, I had to rewrite that talk 4 times to keep it somewhat contemporary. You can probably appreciate some of the problems here. At least this one I can reuse. So Semantic Kernel, it's still in alpha, and it enables you to do that kind of slide, that a lot of the steps of the slide before. So do keep an eye out for this one, and I've got a demo for that in a minute. And it's essentially an orchestrator that fulfills asks, so requests or things that you feed in the model, via functional composition technically. And it supports a number of things. So intelligent planning orchestration. So orchestration is the big thing, and intelligent planning is using GPT to make the decisions for you. And I've got to add an example for that in this talk. Prompt templating, so you would have recalled that section that I did on prompts earlier in terms of the types of prompts you can get. It supports prompt templating and putting this together, but also injecting variables into your prompts as well. And it's got the concept of different types of functions that you can run. It can do semantic and native functions. I'll discuss that in a minute too. So semantic functions are questions that you ask GPT, but can also run your own code within here. But get GPT to run your own code, which is the interesting part. It supports embeddings as well, so the concept of memory, so you can use your own data with it as well. And the concept of connectors. So when we actually look at this, we've got an ask, which is the initial query which goes in. We've got the kernel, which is kind of this orchestration engine. You can either do classic workflows in terms of constructing a sequence of events that you want, or a sequence of steps to perform on the input, or you can get it to intelligently plan it. So you can imagine you're telling it what you want it to do, and it works it out for itself. So that's what I refer to as intelligent planning. And we've got kind of 3 things here. So we've got skills, memory, and connectors. And it goes through this process of whatever that looks like, and you get the result. So do keep an eye on this. Still is alpha at the moment. But yes, let's have a look, finally. So perhaps something which is maybe a little bit more interesting. Just put on my glasses. So it would be nice to wow with websites and everything like that, but unfortunately I've got only so many hours in the day. I've got a very simple example here. So, sorry? Okay, I need to work out how to share this. Thank you. I only got this Mac last week. I'm still learning how to use this properly, so I appreciate it. Do feel free to speak up if I don't seem to know what I'm doing as far as operating this anyway. Okay. So in this I've got two demos. In this case I'm using Azure OpenAI, just to be clear. So I've got that in my Azure subscription. I won't open that up. I've got 3 models deployed in Azure OpenAI. I've got an embeddings model, I've got ChatGPT, and I've got a text completion model. If anyone wants to have a look, I can open that up afterwards. I just don't have all these windows open right now, and I don't want to spend too much time doing it. Okay. So what we'll do, what is this? I've got a Word document here. And this is a little bit about my experience, assuming it's going to drag on the screen. Okay, that's all right. It's not critical. That does work. Okay, let's just start off. Everyone's waiting with bated breath. Just have to see if I started things off or not. Okay, right, it looks like we might be up, we'll have to see. I'm going to drag this window across. Okay, is this big enough, or would you like me to make it a bit bigger? There we go. So this is just a simple console app.
It's okay for the front row.
Okay, no, it's all right. I can bring it more.
It's okay. It's good.
Okay. I'm just going to put down the mic a moment because I need to type. Actually, I'll try and do it one-handed. So this is using Microsoft Semantic Kernel, to be clear. And if this doesn't work, I'll just start up the model in a minute. Okay, so I'm talking to myself apparently. Jack Watts, lead consultant with experience, blah, 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 Australian, etc. So, okay, that's interesting. Salad and factory automation, hospital admission system, operations research, routing, etc. Websites, augmented reality, machine learning. Okay, so that would be helpful. Thanks, Todd. Okay, so what have you done with machine learning? I love this pause for effect. Okay, so in 2020, I worked on a machine learning project to optimize operation throughput at a zinc plant. We use sensor and blend inputs, etc., etc., and then it goes into the different certifications, etc. So, okay, well that's interesting all. Sorry for another minute. What have you done with augmented reality? Okay, 2017, HoloLens. Okay, what projects did you work on in 2018? Okay, so there's some interesting things here. So yeah, you can probably guess it's almost as if I'm talking to myself, but I'm actually talking to GPT here, and I'm using Microsoft Semantic Kernel to do it.
So I feel like you trained this on your resume or something, right?
It's actually just a skill thing. I'll show you that in a minute. Assuming I can bring this up. I can navigate these screens well enough.
Has it been obviously taught in the States because of its English spelling?
So specifically what I did here, it's a very simple example actually when you have a look what's going on under the covers. Yeah, just give me a moment. Apologies, it's a little bit slow. Once again, it'll be greater if I was a little bit more familiar with the tooling here. Okay. I think I might just spend my time in this editor. Okay, specifically, the code is going to be a little bit small, but essentially I've got a Word document sitting there on the system. I read the Word document into memory and then query the Word document. So the way that this is happening is there is a connector, and I'll just show this very quickly. I realize it's going to be a bit small. But these programs are actually remarkably simple. So I've got something referred to the project history example here. I realize it is extraordinarily small. So got a very simple thing here. I've got something which is reading from a particular Word document. So if I could work out how to get to Word, I've got something called project history 2, which has got customer names removed. And then basically I'm creating a new context using Microsoft Semantic Kernel with OpenAI. And I've broken that document into a number of sections. And for each section, I'm calling Azure OpenAI the encoding space to go ahead and create a semantic memory of each part of that document. And then I'm storing that in a local vector database. So specifically, I've got a database there running on the system, so something referred to a vector database. If you look around, you'll see there's quite a few of them, which is in storing those vectors which are being created from those parts of the document. So when I go ahead and query the model, it sends the request to the vector database. I've got a number of responses that it's going to get back from that vector database, and then GPT processes the responses. So I realize that's probably very brief and quick high-level overview of what's going on there, but I will try and bring up something which is a little bit more interesting around that. So to understand how complicated it is, this code file, you can probably see at the size of the scroll bar here, it is relatively small, and the actual magic is happening here. And this is what I was referring to as a prompt template. So I'm a consultant who answers questions according to my experience. I ensure my responses contain only the most relevant information to the questions I'm asked. Consider only my experience when writing a response to answer a question. My experience, I'm calling a function here called recall. I'm feeding in the query that you would have seen me type in that window. The question is the query. Answer, you would see this kind of thing where I had the public, etc. before, and it's simply going to go ahead and produce the response. And yes, that was not too difficult to do in terms of it's just, a couple of hours work. Most of my time was actually spent, one thing, I spent a little bit of time trying to get the prompt right. The other part was trying to space out the document. I was going to do another one internally for kind of a more complicated example, but I think this one's probably sufficient for the moment. Okay, I do have a second example now, which might be a little bit more interesting. Okay, I will need to start up another app for this, just for a moment.
So that prompt template, is that in addition to the prompt that you actually spoke?
Yes, that's correct. So what would happen is where you saw that the two curly braces and the word input with the $sign, that dollar input is what I typed in, and it's embedding it within that prompt. Similarly, when you saw the curly braces with the recall, that's calling something called the recall function, and it's injecting them a prompt there. So it's this kind of inception or nesting of information. That's how you start to get kind of this performance, because you could clearly see that it appeared to be looking at that profile history document. Okay. This one is a little bit more interesting. Okay. Just to be clear, I've pretty much been a Windows user for most of my life. I only started this last week and my current laptop is unavailable, so it's in for repair. So
Escape should get out, I think.
okay. Pardon for the painful demos here. Okay, that's a little bit better. The irony is I've still got Edge, Outlook, etc. on here, so. Okay. So let's go ahead and run the second demo. So the second demo, I'll just go ahead and change it to Azure 2. Once again, this is using Microsoft Semantic Kernel. This screen seems a little bit big. We'll just try and drag it across. Okay, so what we're looking at here is a weekly report I've done for a particular customer. Once again, hopefully everything out of there. But the kind of typical thing, deploy the test environment, been running orders through, blah, 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 add support for custom frames, packing plans, email alerts, etc. next week, impediments. So typical kind of update there. Okay, let's start and see what we're going to do here. Press enter to launch. Yes, I love the pauses. Okay, that looked interesting, but what was actually happening there? But not just that, it is actually quite a more sophisticated than it might actually look. So, there's, okay, it's a very sensitive position. Okay, so, what I've asked it to do here is a multi-step process to take this input that I've just put up there. So you can clearly imagine I could just type it in, but I don't have the time to do this right now, despite all the other technical issues I'm having right now. And we've got it going through a number of steps. So the result so far, I'm getting it to summarize that report. Step 2, I'm getting it to translate. Step 3, I'm actually getting it to email me, and step 4, it's emailed me. And this is where I'll explain. Trust me, it should have, maybe there's a little bit of delay here on my email, but that's okay. And we will just go ahead and stop this. This lag is a little frustrating. Apologies, the demo is almost over. Okay. Apologies, just one moment here. Control C will work out. Okay, well, come on, this lag, stop. Okay. Right, so what was that demo all about? So specifically, we've used intelligent planning in this particular example here. This is a planning example, and I'll show you what I've actually done here. So once again, relatively short file here, but some basic kind of boilerplate, which a lot of people are familiar with in terms of reading, but this is where things get interesting. So what I've done is the kernel, we've initialized the kernel, so you can imagine an initialized kernel probably does what it does. Getting it to import a skill which I've written called the email skill, which I've got normal settings, so this is kind of standard code that a lot of people will be somewhat familiar with. And then I've got to import 2 other skills. I've got to import the summarize skill and the writer skill. And then I've given it the plan, summarize and input, translate to French, and send an email to Jack Watts. That's all I told it to do. I didn't actually give it a particular pipeline. And so what I've told it to do is essentially that piece of text. And the plan is just what I showed before. Summarize and input, translate to French, and email to Jack Watts. So the email should have come through. This is all the more impressive when it does. I won't delve too deeply into that. But specifically, I've loaded 2 things. I've instantiated a class called the email skill. And what I've done with this class is the way that's had the ability to call this particular class is by some human readable data machine readable data that I put up here with human readable data. So the way I've described this function is given an email message body, send an email, and GPT has worked out, that's what this function does. I can go ahead and call it and do what needs to be done there. So if I actually go the references, it's a little bit ponderous navigating through this with the delay on the monitor right now. Specifically, this function is not called anywhere within the app. It is just simply called by the nature of this SK function attribute. Similarly, there is some other kind of files that we're looking at in here, something called semantic skills. So these are the kind of skill, when I was talking about summarize and write a skill. got a summarise skill here, and all we've got for the summarise skill, we've got a particular template, summarisation rules, don't waste words, short and complete sentences, etc., etc. And the way that it's realised that it should call this particular prompt is off config. So there's two ways to do it. You can either do it via code when you want kind of sophisticated things like call an API or do whatever other logic, search AAD, search Word documents, whatever. Or you can go ahead and give it these things which are referred to as semantic skills, which are essentially just prompt templates with metadata describing what they do. Okay. Now I need to work out how to close this. I'll go back into presentation mode, hopefully. Okay, were there any questions around that at all? Unfortunately, the demo didn't quite go how I wanted it to, but hopefully a lot of the underlying concepts were fairly clear in terms of what was going on. The point is this level of orchestration is already there. It's been available in the machine learning space for a little while, so you'll see things referred to, for example, as AutoGPT. But this one is developed by Microsoft. It's likely going to be very similar to what's been running on Office Copilot, etc., as you can probably appreciate, Copilot X. And other tools, Bing AI is going to be using something fairly similar to this, would be my guess. And yes, there's not much of a step, as you can probably appreciate. Since you've got access to code, you can write loops, you can essentially implement this kind of concept of autonomous GPT. So you can feed in one prompt to the other, give intelligent planning or particular pipelines.
So as a use case, that first example, you could point it at a repository of all your policies, procedures, knowledge base articles, and then you could potentially have that prompt available to staff to ask questions about the organisation.
Correct, that's a great question. I was over in France last year, and I visited the bank, and that's what the bank, or I guess teller or advisor was actually using, was something along those lines. So they weren't actually using GPT. I think IBM Watson are the ones who provided ones for the French banking system. But yes, that is roughly what this does, but it's more advanced than at least the IBM Watson offering was then, and likely still is right now. And yes, you can point it to a repository. So the thing is, in that first example, I only scanned one document, but that's just a loop, and you can ingest as many documents within reasonable constraints there. So specifically, you'll be limited by the vector database technology will be one part, and obviously the performance of that. But you can encode all that information in there. So there's a couple of considerations around that. So first thing is each section of the document that you extract, you need to be able to kind of generate semantic meaning from that. So you'd be calling an encoding endpoint, which is going to associate a cost with that. Okay, but you only need to do that encoding once, because once you get the result back, you store it in a vector database. There's multiple vector databases available out there, some open source ones, other ones you pay for a certain subscription for. Depends on what kind of collection that you want to, you can name your collection in terms of policy documents or other types of documents. But there's essentially no reasonable limit apart from the kind of server limitations. From a GPT perspective and a semantic kernel perspective, this one is in alpha. You can probably appreciate there's probably some optimizations around that which can be done to improve performance. Being alpha, there's a lot of churn, but you could see the demos are comprehensive. They do work with what I'm doing. There's likely be a lot of churn in that space, but it gives you an idea what it's capable of, and your limitations will be once again in terms of what that's actually running on. So to be clear, when I was using the intelligent plan in the second example, that's still making calls to GPT, whereas for the example, the first example, it was just a repeat loop which only called GPT up per question, because all that data was already encoded in the database, in the vector database. Hopefully that roughly answers your question there. But you could appreciate how that scales, because I'm using the Word document connector there. Clearly you could do one for PowerPoint, clearly you could do one for PDFs, clearly, etc. The space from a machine learning perspective, when you're working with Python and machine learning toolset, I'm aiming this talk more towards a kind of developer perspective. It is somewhat more mature. So when you have a look at AutoGPT, for example, or Microsoft Jarvis, I should say, you'll see they've got some more sophisticated demos and connectors there. But it's just a case of coding, like the email one. I've got an email API that I'm using and simply calling that. So the limitations are really kind of up to you, or your imagination.
And the other one, Copilot sort of promotes itself as being ChatGPT with access to your graph data, like the data available.
Yes, yes. Sorry, keep on going.
So I guess the question is that using it with prompts? Is it, or
Okay, so that will be a connector. There is a graph connector in Microsoft Semantic Kernel as well, so I assume there's going to be significant overlap with that. Once again, I don't have any views of internals how that works. The graph data is likely going to be a native skill, so where someone's actually gone ahead and written code, and then it depends on the context it's used. So it could either be in a pipeline where they just call it programmatically, or there could be another option where you could do, for example, that intelligent planning to go ahead and query graph data. And based on the metadata in terms of how the methods are described, it can perform those actions as well. So you've kind of got two routes into it. You can either explicitly call it, or you could get the Semantic Kernel Intelligent Planner, i.e. GPT in the background to do it for you. Okay. I've got a little bit more to go on, but that was the exciting part, despite the delays and technical issues. Right. So yeah, that should have been hopefully somewhat interesting. The other part that I didn't really cover is this concept of fine-tuning, and this is what made the model seem to be more aware of its environment. I kind of talked about this before. Removes the need for examples, so there's a whole concept of one-shot, a multi-shot, zero-shot learning. And in some of those prompt templates, you'll see examples of one-shot examples. So for example, when we're talking about translate this into French or summarize this document, you might provide one example of what a summary looks like. So that's called one-shot learning. It goes into the prompt, goes from there. But what fine-tuning allows you to do is tweak the base model according to your requirements. So yeah, removes the need for example. It's an advanced use case supported by OpenAI and Azure OpenAI, of course. Then the implementations for the APIs have got significant overlap. They look at the same apart from some metadata which is associated with it. And this is the kind of thing that you can use to make the model use some domain-specific language, for example. So the thing is, for example, you might be in a particular field which there's a lot of domain language that needs to be used in that field, and just putting that into the prompt is going to consume a significant portion of the prompt before you even get to ask your question. So in that particular cases, you would use fine-tuning for that. And I've got a very brief example around that. This one, I'm not actually going to be running any code, so no technical issues. Okay, so the way it works is we're working with JSON-L here, and pretty much key value pairs. We select a collection of prompt completion pairings. We've got a prompt and we've got a completion in terms of the desired result. Once again, as mentioned before, the fine-tuning is going to integrate that and minimize the differences, not necessarily provide that exact result. And doubling of dataset results in a linear increase in performance there. You can put up to 200 megabytes of data at the moment. That's just a technical limitation right now. Only available for non-fine-tuned models, i.e. pre-3.5 models. So I don't have access to GPT-4 because I haven't gone through the application process yet. It's not available for GPT 3.5 because these models have already been fine-tuned. When the models have already been fine-tuned, they're not allowing additional fine-tuning on top of that. So it could be a technical restriction or some other kind of conscious decision there. I don't have any insights as far as that goes. Yeah, offered by both OpenAI and Azure. It's approximately $30 to $125 an hour, but it depends on the amount of data that you want to push through, etc. in there. So there's only kind of a rough estimate in terms of which model you're training, etc. But give you an idea what the cost. So it's not necessarily a lot because you're not going to be doing it for days or weeks. And if you want to know more, check out Microsoft DeepSpeed. Once again, I've got the reference on fine-tuning. I've got a DeepSpeed reference later on. So what's next? So we're kind of familiar with this. GitHub Copilot X, GPT-4 based, Microsoft 365 Copilot. You could understand how at least some of that would be working behind the scenes. It's just a case of prompt injection and a number of other things. No doubt a degree of fine-tuning for both of those models which are being used to go ahead and get access to the underlying Office APIs. So it's from there to be able to go ahead and perform whatever you need to do. I didn't have the time to put together a demo for that, but I could certainly do something like that with Semantic Kernel. And just give me a day or two of free time. And yes, and there's also GPT-4 for Azure OpenAI as well. That's just a two-step application process for that one, and a Microsoft partnership kind of thing. And yeah, this is essentially my references. So you can start developing a platform OpenAI, Azure OpenAI waitlist. There's the first application there. There's a series of applications to get through to these, but maybe you can shortcut them one way or another. GPT-4 API waitlist there. If you want to go into some of the research papers and try and work out, okay, why does Jack seem to somewhat know at least some of the things that he's talking about? Whole lot of research papers there you can have a look at. Attention all you need research paper there. Microsoft Semantic Kernel, have a look. That's what I did my demos on. Microsoft DeepSpeed. You can do fine-tuning without DeepSpeed. It is just trying to reduce the, make the process easier for you. And Microsoft Jarvis as well, which is the equivalent of AutoGPT, but mind you, you could essentially implement AutoGPT just using Microsoft Semantic Kernel. So I assume there's a degree of overlap there. Just to be clear with Microsoft Javas, from what I've seen, that's more in the ML space, so that's kind of developing with Python and a number of other things like that. It's loading the model into your local system, and there's a couple of other things I didn't touch on with whether it's Javas or Microsoft Semantic Kernel. Just talking about OpenAI and Azure OpenAI. You can also get other models, for example, from Hugging Face or other providers and integrate them with that. It's just the connectors aren't as developed yet, being in the early phases, and I'm sure the community will go ahead and pick those up and develop them, or you can develop them yourself. It's not a difficult task. It's essentially just calling the API with the appropriate prompt and the appropriate tokens. So tokens as in your API keys, etc., or metadata. Or if you've got a locally hosted model, so this is relating to the question which you got earlier on the call about performance monitoring, etc. There's a whole space in that. I'm not going to dive too deeply into that. As far as deploying these models there, you can obviously deploy them in the cloud. You can deploy them on-premise, depending on which cloud offering you're working with. They've got a number of tooling options there and going into different deployment strategies and monitoring for that. That's a whole different topic and talk. But there are other models that you can use with this. It's just with the GPT-based models, you will not be able to do that. You'll be going through this layer through Azure or OpenAI. And that's essentially all I've got. Any more questions?
Which GPT? You should be using Outlook, not Gmail.
I've got an Outlook and a Hotmail account. That's what I'm using the thing, but it's just my general access is via Gmail. That they're oriented towards other things. Anyway. Okay, thanks everyone.
Actually, sorry, Jack.
Yes.
Comment. In terms of the training of these models, are there plans to do more than 2021 data, or are they?
So that's a good question. The assumption is yes. There's no explicit statement, but it seems to be fairly clear. Okay, just to be clear, there is a slight difference between the models. Last time I looked, which was about a month ago, so it means I can be completely out of date. That's just how fast this field is moving. I saw another model which is as part of the way into 2022. So it's an assumption that moving forward, some of these will inch forward. However, keep in mind that restriction on terms of the data available isn't necessarily important because you've got so many ways to plug it in. The thing is I could do another example, for example, using Bing search or Bing customized search, depending which offering that you're using, to go ahead and get your results back. So that is certainly not a limitation. It's a limitation in terms of general public use using the ChatGPT interface by itself, but there's no reason why, and that's the thing, I could spend hours talking about this, which is fairly clear from this discussion. It's up to you. So if you want to issue a Bing search or another search to go ahead and retrieve your data, you can. So you can get up-to-date contemporary data on any given topic. It is just, probably the way to look at that initial training process is just its ability to put together coherent sentences. And so this semantic map that's formed, probably the biggest benefits will be expanding that into other languages because there's going to be somewhat of a bias towards English. But in terms of the facts, etc., you will not typically want to be using this for retrieving facts. If you're talking about particular processes, so for example, if there's a new project management process or another process for performing something, you are just simply better using a search engine to go ahead and query that and inject that into the prompt and then go ahead and summarize that. So classic example is there's some people who have a job as training people how to code, and they've got YouTube videos, etc., all about that. That gets pretty much all blown out of the water by GPT-4 because I can just go ahead and point it at an arbitrary documentation, fetch all the links for that, clearly like as per the Word document. 32,000 tokens gives me a fair bit of space. I can issue a search and then just say, write me a class, explain this like I am X, how to go ahead and do this particular task. And then you could clearly see from at least that memory task that I demonstrated, just simply issue the query, integrated in the prompt, summarize and explain it like I'm 5 or explain it like I'm X. So.
And to ChatGPT-4 or GPT-4, would it be been trained again from scratch, or have they taken GPT-3 and just enhanced on top of it somehow?
I can't answer that question. There will be a lot of overlap in terms of how GPT-3 has been trained. However, there's the interesting thing about transformer models, they've been successful since that attention is all you need, so 2017. And a lot of the tweaks, there's no revolutionary approaches in that. And I suspect that's part of the reason well, I realise they're not training GPT-5, but their standard approach that they took the leap between 3.5 and 4, I think they've hit their limits momentarily in terms of, once again, diminishing returns in terms of the amount of effort that you put into get the desired result. So they need to try some different approaches. But to be clear, there's some clear differences between GPT-4 and GPT 3.5. For example, automating this, the kind of irony there and the reinforcement learning with human feedback, there's less human feedback involved in that because you can go ahead and train an AI to go ahead and train the other model. And there's a number of other things which kind of feed into that. So there's a lot of micro optimizations along the whole chain which has resulted in GPT-4. But I get the impression they're looking for something new. And as pointed out before, there's this concept of hallucinations, nesting and jailbreaking, which cannot be avoided just due to the very architecture of some of these models. Any other questions?
Yeah, you mentioned people talking about their data in there, but is it the case that it's not really their data, but the vector space that's being developed by ingesting the data?
That is a good question. So from the creative industry, I'd argue yes, to an extent. So it goes both ways, right? The thing is hopefully this doesn't come out the wrong way. We like to all think that we're unique. With the advent of the cloud and data collection, social media, etc., as different as I might appear to the person next to me in some regards, there's a lot of commonalities here. And so regardless of whether or not my data has gone into the cloud or someone else with similar personality traits or similar traits to me has gone in, that has been modeled. So I'm going to give a really trivial example, probably relevant to kind of awareness of some of the security expertise of some of these people in the audience. Just do randomized passwords now. I've been doing it for a couple of years, but before then, I've looked into kind of memory techniques and peg lists and all sorts of things like that to go ahead and pick an arbitrary domain and then create an alphabet and then go ahead and generate a password for a given site with inserting random characters essentially. The problem is that might seem somewhat smart, like a lot of people who know security will say, okay, that's pretty dumb, but as a naive person, that's what I had. I thought, okay, yes, I'll go ahead and put in this particular space, I have the peg list, go ahead and generate a series of words to go ahead and do that. The problem is even though that might seem uncommon, or in terms of maybe only 1 in 100 people do it, or maybe 1 in 20, I don't know, but the thing is whether or not they've got me or someone with the similar kind of traits to me in the system, it does not no longer matter. I'm being profiled from the social media age, I've been profiled from this kind of irony in terms of the general data protection, in terms of cookies, etc., and my behaviours. It doesn't matter. Someone similar enough to me has been gone into the system. So this thing which will say, oh, okay, this is unique to me, I'm creative, I'm wonderful in this particular regard, I'm probably not unique among 3 billion people or 4 billion internet users. That's just simply the harsh reality of it, and we need to kind of come to grips with it. So that's kind of the issue that the creative industry kind of struggles with at the moment. As far as getting specifics around other things, the Samsung issue was a real issue. That was due to data collection from their interactions with the GPT. So once again, the model isn't being modified itself, but the thing is clearly to improve the performance of the model, you want to get an idea of how people are using it. There's no doubt some sort of automated process, at least in part of that, in terms of collecting that data. That data maybe was not curated as well as it should be, and is now part of the model. So as far as trade secrets and those kind of things like that, you need to encourage your staff or co-workers not to put that into there unless you're familiar exactly with what the restrictions and limitations are of the particular model that you're working with. So for example, with Azure OpenAI or OpenAI, you need to be familiar with the fine print. So from a creative standpoint, it's a bit of a murky space. From the technical trade secret standpoint, it is a real issue, and you really need to understand the fine print. So in some cases, I know, for example, ChatGPT, there's a period of 2 to 3 months that they're saying they're not collecting data anymore, so you're probably safe to use it within that period, but then when did it turn back on again? They didn't have an explicit statement when it got turned back on again. So it's just user beware is probably the best way to sum that up. Any other questions? Okay, without anything better to do, I guess I'll wind up. Thank you very much.